Guys, we made it. We made it. I am in the Bahamas. You can, yeah, this is the very first video, very first live, and I'm going to be going through a functional maths past paper. We're going to be going through um, functional maths, paper one, right? Section A. This is the functional skills hour. I'm just going to be going on for an hour. You can come along with me if you find this useful. If you're someone who has not done maths in a very long time, it's all right. I'm Roy. My name is Roy. Um, as background, I graduated with a degree in engineering um, from a pretty top university in the UK. And I've been teaching maths for the past 9 months or so. And I think maths is something anyone can learn. I don't think it matters at what stage you are in life. If you happen to have an ambition, you want to become a nurse, you want to become a psychologist, an accountant, an electrician, but you don't have a maths qualification, it's not an issue. So these lives are meant to be just me going through a past paper for around an hour, and I do these every single day. Um, so please join me. It's every day at 2 p.m., 2 p.m. UK time. So, tune in. Anyway, let's begin. Let's jump right in. I'm gonna see 1 hour. I'm gonna put a timer so I don't forget. Right now it is okay. Let's see. 1 hour timer. Google has everything these days. There we go. 1 hour's begin. All right, let's jump in. I'm gonna put my signature. No, I'm not gonna show you that. Just gonna put my name. I don't want you guys stealing my identity. Don't want that. This is a 25-minute paper, right? This section A is only meant to be 25 minutes. So we should be able to finish this pretty quick. Some important things to note is that in section A, calculators are not allowed. You want to answer with a black ink pen. You want to fill in the boxes on the top of this page with your name. I've done that. Actually, I haven't done that, but you would have to do that up here. You want to sign the declaration. So down here or up here, you sign that you confirm. You want to answer all questions. That's really important. Even if you don't understand, just put something down. It's better to answer than to not. Write your final answer in the boxes provided. That's an important one. You don't want to put your answer somewhere just randomly on the page. You want to put it right where the box is, usually at the bottom right corner. All right, answer the questions in the spaces provided. There may be more space than you need. You must show clearly how you get your answer in the spaces provided. Marks will be awarded for working out. Okay, that's really important. Well, I'll show you how to show your working. That's half of the marks, if not more. Check your working and your answers at each stage. Diagrams are not accurately drawn unless otherwise stated. Calculators may not be used. I already said that, and this is important. Take the value pi, this is the Greek letter pi, to be 3.14. Okay. That's an approximation because this is a non-calculator paper. All right. Total marks for this section are 16. Marks are shown in brackets. This sign shows where marks will be awarded for showing your checks. Okay. Final piece of advice. Read each question carefully before you start to answer it. Check your answers if you have time at the end. All right. Let's jump in. First question. Work out 5.2 times 9.6. This right here is a classic question. To do this, we just want to do normal column addition. That's the first step. But before we do it, we want to count how many decimal values there are, right? There's one, there's two in total. There are two decimal values. Once we keep that in mind, we can multiply as usual. 6 times 2, that's 12. 6 times 5, that's 30, plus 1, 31. 9 times 2, 18. So we put the 8 here, carry the 1. 9 times 5, that's 45, plus 1, that's 46. Carrying on from here. And put our place holder 0 right here. Then just add these partial products. 2, 9, 9, and 4. Okay, but now we will remember that there are two decimal values, and so we want to make sure our answer has two decimal values. So the decimal point will be here. So our final answer is 49.92. All right. Next, let's work out 4 times 3 squared. Well, this is again BIDMAS. We know that 3 squared is 3 times 3, right? So that's really 4 times 9. 4 times 9, that's 36. All right. We're going quickly. Finish question 1. On Thursday evening, Malcolm's bank balance was this. All right. On Friday morning, he paid this amount into his account and paid this amount out of his account. No other payments incurred. Work out how much money is in Malcolm's bank account on Friday evening. All right. So we're told that Malcolm started out with this amount. And he paid this amount into his account. So he added, his bank balance increased. So we want to add these two. All right? Let's do that first. 5 plus 8, that's 13. 6 plus 3 plus 1, that's 10. 7 plus 7 plus 5, that's 15. 6 plus 0 plus 1, that's 7. 8 plus 1, that's 9. And 1. Making sure to put our decimal point where it was, right here. Okay, next step. We're told that Malcolm paid out of his account this amount. So we want to subtract this amount from this amount. 715. And we'll take away 715 pounds from this amount. 3 minus 1, that's 2. We can't do 2 minus nothing, so we borrow a 1 from the next place value. This becomes 4. This becomes 10. Now we can take away 2 from 10, so that's 8. But look, now we can't take away 5 from 4, so we repeat that. 5 minus 14, that's 9. 6 minus 1, that's 5. 2, 1. All right, all right, all right. Now we have our final answer. Malcolm, on Friday evening, had this amount. 1,259 pounds and 82 pence. There we go. Pretty simple, but actually pretty tricky. You could easily make a mistake here. You want to take your time. Next, question 3, we have Akash. We've already done, let's just look back, right? We've already done 2, 3, 6 marks. We've done 6 marks, and there's 16 marks, so we still have a ways to go. Akash needs to put plastic trim on a shaped window. The window is made using a rectangle and a semicircle. The diagram shows the places where he needs to put the plastic trim. All right. This is the plastic trim. Now we're told Akash estimates that he will need 700 centimeters of plastic trim in total. Use estimation to check if he is correct, basically. We must show our working. All right. What are they really asking? They're asking us, what is the total length of all of these sides in black? What is the total length? Because that is what will that's the path that the plastic trim will follow. So we want to find the total length. This rectangle is pretty easy. Its perimeter is just going to be the sum of these 4 sides. It's going to be 118 plus this side, 113 plus 118 plus 113 again. Those are the 4 sides. That's the perimeter of the rectangle. Next, we want to find the perimeter of this semicircle. So let's think of that. But before that, actually, let's find the lengths of these sides. These little these radii actually. So the length of this radii, let's say it's r. If this is a semicircle, we can be very sure that the length around from this point here to any point on the circumference will be equal to r. And so this one here is also equal to r. And guess what? This length is just the difference between this length and this length, right? Or in other words, it's just this length, 59. So R is actually 59 centimeters. Perfect. So from there, we can see that the circumference, the circumference is going to be, this is a formula. You should know this. The formula of the circumference of a circle is 2 pi r. But notice that this is not a full circle, but it's half a circle, right? The circumference of a circle is 2 pi r. But this is not a full circle, this is half a circle. So we actually want to take half circumference. That's just pi r. Half of 2 pi r is just pi r. Okay. So that means that length is pi times r, which is 59 times pi. All right. This is important. This is important. And this is important. We want to, well, let's go back here. We know that R was actually just one of these lengths, so we want two of them. I want two of them, R and R. Let's do 2R. 2R will be double this. That's 118. You can do that here. 59 plus 59, 18, 100, or 10, 11. So 118. So now we can just add all of this together. Let's find these. Let's actually evaluate these together. 118 plus 113, that's 11, 3, 2. Now we could, add it again, but we could have just multiplied this by 2. That'd be 2, 6, 4, 462 centimeters. Finally, 59 pi. We were already told that pi should be approximated as 3.14. So, oh, I forgot. This is a rookie mistake of mine. I ignored a very important point. This is a lesson. You're probably wondering, Roy, why are we taking so long? This question is only 4 marks. We've been at this for the past ages. You'd be right. I entirely forgot this point. This is an estimation question. We don't need to be perfectly exact. Right? We don't need to be. I could have been much more rough with my measurements. So really, I could just say, well, this is around 60. Pi is around 3. So this is going to be around 180. 60 times 3. Right? And now we have 460 plus, just add these roughly. 460, 120, 180. Let's add that. That's going to be 4 plus 3, that's 7. Yeah. So he's about right. This is a sensible estimate. 760. So we can say, yes, it is sensible. Because 700 is pretty close to 760. All right. So that was a rookie mistake. We want to estimate. We want to estimate. Next, question 4. This is a much longer question, so I should really pay attention this time. It's the last question. Calvin is a train company manager. He compares the arrival times of a morning train service for 10 days in the summer and for 10 days in the winter. In the summer, the median number of minutes late was 12.7 minutes. The range was 11 minutes. The results below show the number of minutes late in winter. Calvin thinks that in the winter, the median increases and the train service is less consistent. Is Calvin correct? All right. This is a statistics question. Let's remind ourselves what the median and the range are. Remember that the median is the central piece of data. It's the data that's found right in the middle. When you order the data from smallest to largest, the median is the one right in the middle. The range, however, that's the difference between the largest and the smallest. All right. And so let's looking at what Calvin says and looking at this data, before we can verify Calvin's claim, we have to order this data from smallest to largest. All right, so let's do that. Winter. This is the winter, I guess, data. I'll just say data. I could say minutes late. The smallest would have to be 5. Next, we have 8, 9, 10, 14, 17, 26, 32, 44, finally 67. All right. So this is the order. So the median, let's find the median. That would be the middle data. So we can just, what we can do to find it is we can cross out each term starting from the outside, moving to the inside, like so, until we reach the central value. So that's it. Ah, look, here we go. So we see that there are actually two central values. When that happens, what we do is we take average between them. The median will be the average between 14 and 17. So right, remember to do that, we add them, and then we divide by 2. That's going to be 31 divided by 2. 15.5 minutes late. Now let's find the range now. Should be quite simple. The range is simply the difference between the largest and the smallest. That's going to be 62 minutes. From here, we can now look at Calvin's claim. Calvin says that the median increases in winter. So we can see that in summer it was 12.7. So yes, Calvin is correct on that point. We say the median does in fact increase. It was 12.7. It is now 15.5 minutes. Second point, is the train less consistent? Now, what that means, less consistent, that has to do with the range. Because if you think about it, um, consistency is about how reliable is this train, right? Usually, does it come at around the same time? And so if a train is consistent, the range will be quite small because generally it comes around the same time. So if the range is large, the train will be inconsistent. So we're going to see that in winter, the range has increased. So it must be less consistent. So, so I'll write that. So the train must be less consistent. Simple. That's it. There's loads more space given. Really, I should have put my answer right here. But I don't want to write that again. So that's fine. So that is section one done. Section A, I should say, done. We've done the non-calculator part of this. So hopefully that's a good place to pause. All right. Let's see. Yeah, yeah, yeah. The chat is. Remember, guys, that you can ask. Yeah, no, I'm not actually in the Bahamas. I'm not actually in the Bahamas. Yeah. Spoiler, yeah. I'm not in the Bahamas. I wish I was. The weather here in the UK is it almost feels like the Bahamas at this point. So maybe I don't want to be in the Bahamas. This is good enough for me. Yeah, chat. Yeah, yeah. Mm-hmm. Yep. Mm-hmm. Okay, no, so how it works is that functional skills is is the equivalent of GCSE. Um, both of them are level two qualifications. That means there's secondary level qualifications. Even if you look at the name GCSE, it stands for General Certificate in Secondary Education, right? So it's a secondary level qualification. And functional skills level two, if you're taking level two, is also a secondary level qualification. And most employers and many unis accept functional skills maths level two. And so yeah, if you're thinking of taking especially an access to higher education diploma course, functional skills is usually almost always uh, a way in. So yeah, if you're trying to do nursing, you're trying to do something like that, that is your way in. Totally. Yeah. Yeah, no, remember that if you haven't done maths in 20 years, um, it's something that anyone can learn. Um, remember that this I started this career maths club to actually give you the resources to allow you to pass. So we have some of um the best resources if you do want to pass. The problem with other courses out there is that a lot of them assume a lot of knowledge. The ones you find on YouTube, they assume you are already being taught in classrooms. And so they don't go over very basic things like how to do column multiplication, why do you carry the one? They don't really explain these very basic concepts because it's assumed that you've been going through the school system and you learned that in year six, year five. And so they just take that for granted. The thing about this course is that we don't take that any of that for granted. And so yeah, you can totally master the maths that you need in the Career Maths Club if you want to get a premium membership. Yeah, it's quite affordable. I would definitely say people have told me they're surprised how affordable it actually is. So yeah, if you can afford it, I would definitely go to the Career Maths Club and sign up. Okay, guys, that's the break. Let's move on. Let's go on to section B. Yeah, thank you for the questions. Thank you. Honestly, it's really, really, it's really helpful, you know? It's really helpful. Let me see. Here we go. Let's continue. All right, here we go. I think that should work. Oh, that's not what I want to show. Give me 1 second. Mm, 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 mm. Yeah, here we go. Wonderful. Section B. So I'm gonna pull up the calculator because this is a calculator test. They expect you to use a calculator in section B. And it's a much longer time span. You see 1 hour and 30 minutes. That's a lot of time. That's a lot of time. All right, so you can really see how most of the functional skills is favors calculator questions. So you really want to get comfortable using the calc. All of the exact same instructions as before, but now we have 48 marks in this section. Let's jump in. Adam works for an agency. His hourly rate is 8.32. The agency asks Adam to work 6 hours for a new company. Adam will be paid time and a third of his normal hourly rate. Okay, how much will Adam get paid in total when working for the new company? Doesn't sound like a very good deal, does it? All right. So Adam is paid 8.32 currently, and he will now be paid a third of his hourly rate. So a third, we would have to divide this by 3. Now he works 6 hours, so we would have to multiply this by 6. Now, this is a trick. It's called cancellation. Instead of multiplying all of this out, dividing this, then multiplying, or whatever, you can look at this on a larger scale, zoom out, see that we're dividing by 3 and multiplying by 6. That's the equivalent of multiplying by 2. Okay? 832 times 2. Because 3 goes into 6 twice. So this is the same as 832 times 2. Let's just find that right here. 2 times 2, 4. 3 times 2, 6. 8 times 2, 16. We have 16 pounds and 64 pence. So that's it. I'm going to be going quickly for this one. Here we have a square-based pyramid. Work out the volume of the pyramid. Well, we're given the formula right here. It's going to be a third times the area of the base times the height. So let's find the area of the base first of all. Seeing as this is a square, the area of a square is simply the length times the width, right? So it's going to be 8.5 times 8.5. Finally, the height, well, it's just, they tell us, 12.6. Now, they didn't tell us to estimate this question, so there's no reason for us to. We literally just plug this in into our calculator. If you're worried about this third, remember, the order of multiplying doesn't matter. We could multiply all of this out first and then divide by 3 if we want. So that's what I'm going to do. 8.5 times 8.5 times 12.6 divided by 3. That's 303.45 centimeters cubed. We're done. I'll write it right here for accuracy. Question 3. We're really going quick. Rana donated to 4 charities last year. She gave £175 to each of these charities. This year, Rana wants to donate the same total amount between 6 charities. Each charity will receive an equal amount. How much will each charity receive this year? Okay, Rana donated 4 charities. She gave, okay. That's interesting. Okay. So this question is there's there's a slow way and there's a fast way to do this. Let's see the slow way. If Rana donated to 4 charities, giving each of them this amount, the total she gave them will be this amount times 4, right? Whatever that is. Now, I could be slow and plug that into my calculator and find what it is. 175 times 4 is 700, all right? That was last year. This year, she planned to donate the exact same amount, but to 6 charities. So now we want to do 700 divided by 6, right? So we want to do 700 divided by 6. Let's find that. That's 116.67 rounded pounds. That's it. So honestly, it actually isn't as slow as I thought. It's pretty fast. It's really not that slow. The other way you could have done it was that 175 times 4, then divided by 6. 175 times 4 divided by 6 is the same thing as times 2 divided by 3. So we could have done that, but really doesn't change much actually. So we're done. Use reverse calculations to check your answer. Oh wow. Okay. Simply we can do this. 116.67 times 6 should equal 700, right? And it does. I've obviously rounded, so it's going to give a slightly different answer, but if you put it's 700. Now, 700 divided by 4 should equal what we had before, 175. And it does. So that's the checks. Question 4. All right. We have Samir. Samir is on he's a roofer. He's not on a roof, but he's a roofer. Here's a section of a roof made from straight pieces of wood. Okay. Samir knows that the shaded triangle is an equilateral triangle. The line DB is a line of symmetry. The line ABC is a straight line. The size of the angle, marked S, X indicates the pitch of the roof. The table shows the information about the pitch and angle of a roof. Okay. Very, very interesting. Find the value X and use the table to give the pitch of the roof. Very, very, very interesting. So this question, um, This is an interesting question. Yeah, this is a very interesting question. Yeah, this is stumping me. Mm, the shaded triangle is an equilateral triangle. Okay. And that DB is a line of symmetry. All right. That's interesting. Huh. Okay. It's quite a tough, this is quite a tricky question. I've never seen a question like this, quite like this. Let's see. I suspect if this is an equilateral triangle, then we're dealing with a 60-60-60 triangle. 60 degrees here. Right. Now, if that is true, we know that this right here is, if this is a line of symmetry, right? Or, let's not even assume that. Let's say we know this is a line of symmetry. So this must be 60 as well. This is also an equilateral triangle. And equally, if this is a line of symmetry, then whatever this angle is, this is also equal to that angle. All right. We know that on a straight line, we know that ABC is a straight line. On a straight line, the sum of the angles are 180 degrees. Always. That is how it is defined. That means that the angle ABC, which is y plus 60 plus 60, that's 120, plus another y, so 2y plus 120 equals 180, because we know they're 180 degrees in a straight line. We can find y from this. 2y will be 180 minus 120, 60. So y is going to be half of 60, 30 degrees. So this angle is 30 degrees, right? 30 degrees right here. Okay. This is quite a tricky question. I'm not gonna lie. If this is 30 degrees, we know that this must be 60, right? If this is 60, then this is 30. And if this is 30, then this is 60. X is 60. Okay, let me make that absolutely clear. As absolutely clear as possible. We've proven that y is 30 degrees. There's a certain triangle here. This triangle, I'll use yellow. This triangle, let's say this is angle. This is x and this is y. Point x and y. We can say that the angle BXY equals 60. Why? Because the angle, this one here, BYX is 90. And why? Because there's 180 degrees in a triangle. So this is 30, y is 30. This angle here is 90. That's 120. So the remaining angle must be 60 to make 180. So yeah, this angle here, this is 60. And just like before, we saw that 160, 60, 60 make 180. So this angle must be 180. That is angle YXA, 60 degrees. Anyway, let me write that. That's 60. So if this is 60, this is 90, X must be 30 actually. What am I saying? X must be 30. Quite a tricky one. Yeah, it's quite a tricky one. So X is 30 degrees. And looking at this, you can see that 30 degrees corresponds to a pitch of 7. Wow, that is a very strange question. Let me know if you can think of an easier way to answer this. Um, yeah, because I've never seen a question quite like this. And usually with these, there's always a quicker way that you don't really see the first time around. So if anyone can point out a faster way to solve this, um, that would be amazing. That would be amazing. You're gonna get some points. All right, that's question 4 done. Let's look at question 5. Continuing with Samir's roof business. Samir wants to work out the cost of the tiles needed to replace a roof. It has 4 identical faces. Each face is a triangle, and each triangle has a base of this and a height of this. He has this information. Okay, this is a roof tile. One pack covers this area, and each pack costs this much. Samir can only buy whole packs of these tiles. Calculate the total cost of the tiles for the 4 faces of this roof. All right. Okay, so remember, this is a calculator paper, so we can use calculator. All we have to do is we have to find the total area of these 4 faces. So let's find the area of one face and multiply that by 4. So let's do total area is going to be the area of a triangle. One triangle is the base times the height divided by 2. That's a formula. And we want to multiply this by 4 because there's 4 faces. Okay, cool. Just like before, we can do cancellation. 2 goes into 4 twice. So really we're doing 7.6 times 4.8 times 2. Let's see what that is. That is 72.96 meters squared. Now, we want to see how many packs do we need to cover this area. If one pack covers this area, we want to divide our total area by this area. Therefore, the number of packs is going to be our total area divided by 13.8. Let's see. That comes out to 5.28695, blah, 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 blah. Say 5.29 packs. So we need more than 5 packs. So we need 6 packs. Right? Since it's 5 and a bit, we need 6 packs. Now we just take the cost of one pack and multiply it by 6. 716.10 times 6. That will be our total cost. Let's find that. That comes out to 4,296.6. That is the total cost. We're done. Question five. 5 marks, just like that. Question six. Now, we got Farah, 3 marks, with buying clothes from a website. The website shows this information about a jacket Farah wants to buy. Its original price and the sale price. Okay, the website claims this is a saving of 46%. Is the sale price a saving of 46%? Show why you think this. All right, so we want to find the sale price as a percentage of the original price. So we could simply do 16 divided by 30.99, right? We could find that as a decimal, but let's multiply it by 100, so instantly it's going to be a percentage. So that comes out to 51.6%. So this is 51.6% of the original price. Therefore, how much have we saved? Well, we want to find relative to 100%, how much is this, right? That comes out to 48.4%, right? So you have actually saved 48.4%, really 48%. So this is actually not an accurate claim. You've actually saved 48%, not 46%. There we go. Next question. We've got to really speed run it. Here is a quadrilateral. Draw the shape in the grid using a scale of 1 centimeter to 40 meters. Okay, so if one square is 40 meters, we want to find how many squares each side will need. Let's divide each side by 40. We'll get our answer. So that comes out to, this is 4 squares. These are, let's see, 34 divided by 4. That comes out to 8.5 squares. Finally, 22 divided by 4 comes out to 5.5 squares. So we have everything we need. Here we have 8.5. Let's do 1, 2, 3, 4, 5, 6, 7, 8.5. Here we have 4, 1, 2, 3, 4. Here we have 5.5, 1/2, and 5. Just connect the dots right here. We're done. So every centimeter corresponds to 40 meters. So indeed, this would be 340 meters. Okay. Work out the actual length of AD. So this length here. So, we would probably need to use a ruler since I don't have one and I'm on a computer, so it's never going to be accurate. What I can do instead is Pythagoras. Um, but of course, you would measure this with a ruler in the real thing and then multiply by 40. Okay. But let's find this using Pythagoras. We see that this right here is a right angle triangle, right? 3, 4. So this must be 5. This is a 3, 4, 5 triangle. We can see, but if we really don't know what this is, you can say this is equal to the square root 3 squared plus 4 squared. That's square root of 9 plus 16. That's the square root of 25, which is 5. So this is 5 either way. So if that's true, this is 5 centimeters in length. That means 5 times 40, that's 200 meters. We're done. Pablo is investigating the relationship between the land area and the population of 8 European countries. He has this information. All right, Pablo finds out that the UK, this is the land area, this is the population, and it has increased by this percentage in this amount of time. He wants to add this info to the table. He will round the land area to the nearest 10,000 and round the population to the nearest million. He knows that this is true. Square mile corresponds to this amount of kilometers. Okay. So, before we do anything, so let's first, before we draw this graph, let's complete the table. The UK, let's find the land area in kilometers squared, thousands of kilometers squared. First thing we want to do is, we know 1 square mile is equal to 2.6 kilometers squared. So we want, this is how many square miles the UK takes up. And so we want to multiply this by 2.6. This is how many kilometers squared there are. Because 1 square mile is this 2.6. So for every square mile, we want to multiply by 2.6. 93,400 times 2.6. That's 242,840 kilometers squared. Now, rounding to the nearest thousand, nearest, oh, first of all, rounding to the nearest 10,000, because he wants to round to the nearest 10,000. The nearest 10,000 would actually be 240,000 kilometers squared. And so putting that on the graph, that would be 240, just right here. The same size as Romania. Now the population, we're told, increased 19.6% between 2011 and 2018. A lot of parts in this question. So we have 56.1 million in 2018, increased by, what was it? 19.6%. So we would have to multiply it by 1.196. Let me try to fix this right here. Let's see. There's some issues. My mouse. Let's see. All right, that's working now. Here we go. Multiply these two. So this is the nominal value, and this is the percentage, I guess, increase. So let's do that. 56.1 times 1. The 1 in front of the decimal point keeps the original nominal value and adds on how much it is increased. And then we add on what is, so this is 67.0956 million. Okay? In 2018. right? He rounds the population to the nearest million. So that's really just 67 million, right? We can do that right here. 67. Now with that, we are almost done. Let's look at this. We want to plot all of this information, seeing that seeing how does population relate to land mass for each of these countries. So just looking at this, Germany, the land mass is 360, population is 83. So looking at that, 360 is here, right here, 3 squares, because each square is 20. 360 is here, and here each square is 2. So 83 would have to be 2, 4, right in between. So here we go, right here. This is Germany. It's going to be very tedious. Greece, 130 and 11. So 130, that would be here. 11 would be here. It's Greece. All right. Italy, 358. 300 is here. 58, that's right here. It's Italy. Poland is 310 and 39. 310 and 49. 310 will be here. 49 will be right here. Poland. Spain is 510. Oh, Poland was 39, not 49. Let me fix that. Here we go. 39 is here. Poland. So this would be obviously easier with paper because you won't have to keep scrolling. Spain is 510 and 47. 510 is here. 47 right here. This is Spain. Spain. France is 640 and 67. 640 is here. 67 is right here. It's France. Romania is 240, 19. 240 and 19. It's right here. Finally, UK is 240 and 67. That's right. 2467. Okay. Here we go. We're done. You didn't need to put the names next to them. I just did that just to make it really clear. So we're done. We have actually run out of time. We're not really an hour in, are we? But I've been talking a lot. There's still quite a bit remaining. So what we can do is next time, in the next video, we'll continue from here on. Um, this is actually meant to take much longer than this. And of course, I'm talking and explaining as I'm going along. So it's going to take a bit longer than an hour. But tomorrow we're going to go through this and we're going to start where we left off. All right, guys, let me stop sharing. This has been fun. Been a good functional skills hour. Yep. Right, right. We'll keep this up. Keep up the energy, guys. And I'll see you guys tomorrow.